The Matthew McDowell. All right, hello, class. With a couple more minutes. check those dates. So, Mr. Lowry,
Yes, sir.
how
Can
you
you hear me
doing?
okay?
Huh?
Can you hear me okay?
Oh yeah, straight. You all right?
Okay, good.
I wish everybody else turned their mics on, but I guess I'll just have to lecture, hoping everybody understand what's what. Okay, I'll set this there. All right, so I want everybody to sign the roll. Go ahead on and try to sign the roll. Let me know if everything goes all right with signing the roll. And you don't, I took the restriction off, so you don't have to worry about the in-class part. It's just gonna allow, hopefully it'll allow you to sign. And sign every day, well, every class day during the right time, the time of class. Okay, and okay, so let's go. Okay. Did you sign in, Mr. Lowry?
Yes, sir.
All right. So everybody else should be able to sign in also.
It didn't ping me for the being outside of class either.
Right. Because I removed that restriction, being that we wasn't gonna be at school. So like I say, sign in the roll. And what I did, if you noticed, you may or may not have noticed, I created some videos of the remainder of the chapter. If you looked in the SYL site and looked at the list of videos, if you scroll down, you'll see videos, and I do have examples of programs that I did in online GDB. All right, of some examples, and hopefully those little sections of videos will help you. Now, I also use the chapters from the 193 book because it had samples of the program in it. All right. So when you look at the video, you're gonna see the notes, but you're gonna see notes where you're gonna see actual code. All right. But in our book, we don't have code, we have pseudocode. All right. So you're gonna have to kind of be able to relate back and forth. But hopefully you'll understand that part because it's gonna be actual code. All right. What I'm gonna do, I'm gonna post these 3 assignments. I'll go over them right quick. I posted 2 of them already. Let me go to the next one. I gotta turn these notifications on. Uh-oh. I think I did it. All right. Program 2. Okay, let's see what we have here. April 7th, published it. And then the other one, program 1. So how's everybody been doing? Pretty good? Staying out of the streets and stuff, trying to stay healthy, right?
Other than work.
Oh, you still working? Oh, that's good. That's all right. Yeah, that's good.
I got a little paper that says I'm essential.
Yes, all right. Yeah. All right. So before we continue on with the notes, let's look at this program here that I published. It's going to be due next Tuesday at I think at 11:59. It says a student has taken 3 tests, all right, and needs to calculate the average of the test scores, all right? The student is only concerned about passing the class, right? If the student test average is 75, which was 75% or greater, he passes the class. So this is what you need to do. You need to write a C++ program that will allow the user to input, all right, calculate, and only print if he passes the class. So in essence, you're gonna prompt the user either please enter 3 test scores, or you're gonna prompt the user please enter test score 1, test score 2, test score 3. Then you got to calculate the average. There's several ways you could calculate the average. You could do it all at one time by adding them up, dividing, and then getting the average, or you can add them up, get a total, and then divide the total to get the average. All right? However you do it. But now you need to determine whether or not you're going to output something. So that's why the if statement comes along. And so we said here, if the student test average is 75 or greater. So what that means? If they scored a 75, you're gonna have to output he passes the class. All right. If they make a 88, he passes the class. But if they make a 74, then you just don't print anything. All right. Well, and if you notice here, it says if pass, output you have successfully passed the class, right? So that's all I'm saying. That's all you want to output. You want to give an output if that student has passed the class. All right. Now, the second program, a person has a transaction limit of 29. Okay, for a given month at a bank, with their on their bank card. So it says write a C++ program. All right, it should be that will prompt the user to input the number of transactions. So now you're gonna ask the user, okay, and we just doing it as if it's a user. Input the number of transactions. The bank will already automatically probably have that information. But we're going to be inputting that information. If the number of transactions is greater than the given limit, all right, well, really it should be what? Greater than or equal to, because once you reach the limit, it means it's out of, you don't have anymore. So if it's greater than or equal to that limit, then you should output something. And it says you have, well, first of all, if they enter 29 or greater, you should output you have entered an invalid number of transactions. All right. You should enter a number less than, well, not say equal, should be less than 29. I'm going to change that now. Otherwise, now, so you got an if statement. Go check to see if it's 29, right, or less. If it's less than 29, what you're going to do, you're going to say you have, and how you're going to find out the number of transactions remaining, all right? You're going to do what? 29 minus the number of transactions put in. So the transaction limit could be constant, and then you subtract, if it's less than 29, subtract whatever from 29 to get the remaining transactions, and that should be your output. Okay, so that's all that program is doing. So let me change this so if it's greater than or equal, so you won't be confused, to the whatever. All right, and this should be less than. All right, so that way you won't be confused realistically. And that. Any questions so far?
Are we going to use modules?
Oh, you can use, yeah, you could always use, I don't never deter you from using modules. You always could use modules, but I'm not asking for them, but it's a good practice to start using them. Yeah, you can use modules. I don't have any problems with that. Okay. And now the third one. Let's look at the third one. The third one might be a little more complicated because just dealing with the compound and using and or. So it's a bus line. Now you gotta remember this is not realistic. So you're gonna have to kind of put your thinking caps on. A bus line, a bus line has buses with 30-gallon tanks. All right. So the buses have 30-gallon tanks. All right, that it uses to travel to different cities. The company needs you to write a program that will allow the clerk to input the round trip mileage, all right, to and from the city. All right, this is like saying if we go into New Orleans, if New Orleans is like 80 miles from Baton Rouge, round trip would be what? 180, all right? So it says if the miles of the trip, all right, if mile of trip is greater than 0, all right, trip or 0 or less, output no trip program has ended. So if a person puts 0 or -5 or whatever, then what? There's no trip, right? A bad number was put in. Otherwise, prompt the user to enter the miles per gallon, okay, the bus gets, okay? So now you're going to let's see. Yeah, enter the miles per gallon the bus gets. If the miles per gallon is greater than 25, so like say you might have a how would I say, what kind of bus? You might have a bus like they have at BRCC that might get maybe say 30 miles to a gallon. You might have a charter bus might get 10 miles to a gallon. You understand? Or you might have another type bus that gets another mile per gallon. But it's just an example. So you're gonna the clerk gonna allow the miles input the miles per gallon that the bus gets. If the miles per gallon is greater than 25, and so now you got that compound. If the miles per gallon is greater than 25, and the mileage of the trip is greater than 200, so that's two criteria. But you should have a if this and this. Okay, if that's the case, it is not economical to use this vehicle. That's what you're going to output. Otherwise, calculate the number of fill-ups. Now you got to know what? How to calculate fill-ups. If you ever had to plan to take a trip, so like if you had to go to Florida, you would, to calculate your gas, you had to know how many fill-ups that it would take. First of all, you needed to know how many gallons your tank was, and then also how many miles per gallon that your car or truck actually gets, and then you need to know the number of miles per for that trip in order to divide that into the miles per gallon into the mileage. All right. So you need to, if you have to do research, you might have to do some research to figure out how to calculate the number of fill-ups. Now, your fill-ups can be what? 2.5, 2.8, 2 point whatever, 3 point whatever. Because what? 2.5 tanks is a valid number. All right. So now you have to use your what? Your decimals. Make sure you use your decimals. All right. And it says if it says you're gonna output, it's economical to use this vehicle. Otherwise, calculate the number of fill-ups it will take to complete the round trip. All right. So, and this is a hint. Use a nested if and use a combined Boolean expression. So first you're checking on whether or not the value you put in is greater than 0. That's to see if it's an actual trip or not. Then after that, you fall into a nested if, while you're asking if the mileage is greater than this and the miles per gallon and the tank size is whatever. So I think, and so that's your nested if. So that's that program. So that's your 3 programs. Anybody have any questions? What you know, Mr. Calkins? Any Calkins? Anybody? Anybody with any questions? Any questions? All right. So let's move on to the notes. Okay. So let's look at the notes now. Well, before we go to the notes, I'll show you on on the SYL site, what I did was, if you notice, I just added at the bottom, I just added the different sections of the chapter: if, else, if, nested if, programming style, the if, else statement, compared, flags. So you see, I just broke it down into those sections and created I tried to make them as small as possible. Some of them is still 40 minutes or whatever, but you can go to them different sections and watch the video on those sections in the notes, and hopefully that'll help you. And even some of them I wrote sample programs, so you'll be able to look at, when I say wrote them, I think most of them I typed them out and talked them out while I typed them. So you can kind of get the gist of what's going on with the programs and how they work. And we're gonna look at case statements in a minute, all right? So if we go back, this is an example of one. If we go back to our notes, let's see if I can get to my notes. Yeah, notes. So we get to the notes, all right? So we talked about most of the stuff before, all right? But then we had gotten the case statements. And what happened with case statements, I made the mistake of trying to compare a value, whether it was greater than or less than or not equal to. Case statements only find a match for a value. If that value matches this value, if this value matches this, if it matches this value, that's the only way a case statement works, all right? It doesn't actually give a rationale as to whether something is greater than or less than or equal to. All right, so let's look at case structure, all right? The case structure lets the value of a variable or an expression, all right, determine which path path of execution the program will take. And if we look at this example here, this is somewhat as to how a switch statement works, all right? It's an if, but here you have switch and month, all right? So here you're asking to say if month is equal to, but now, what's month? Month is whatever you typed here. Then you're comparing it to say, is month equal January? If it is, do that. Well, if it's 1, display January. If month is 2, print February. If month is 3, print March. Otherwise, print invalid month. So it checked for like what? Just the first quarter, the months in the first quarter. All right. Then the otherwise part is this. The else part would be everything after this. Now, you might say, oh, well, how does that work? Here is a small example, in pseudocode as to how it works. You have the command select. Remember though, you have case, but remember, commands in C++ are always what? Lowercase. So select would be what? All lowercase. Case would be what? All lowercase, right? Give you an example. Let's look at online GDB. Look here. I have this program where I did string. We didn't really need string in here. Our man IP, I got here. C string, we didn't need that in there also. That's header files that I really didn't need. But I need the IO string. Now, we said char let. Now, when I say char let can only be of one what? One single character. Any character I could type on the computer, right? A $, a slash, a question mark, or the letter B, the number 1, right? Char, any character. So it says cout, please enter a character. Then it says cin let. But check this out. This is my switch clause here. And what happens, the switch clause, you have a body. First of all, it says switch and what? Letter. So I want to match, not letter, let. I want to match let. But what I want to match let to? I want to match it to A, the small lowercase a, match it to the lowercase e, match it to the lowercase I, match it to the lowercase o, and match it to the lowercase u. If it's not any one of these, I'm outputting you did not enter a vowel. So the vowels I'm considering is A, E-I-O-N-U. Now, so the switch statement has a body, the open curly brace, the closed curly brace. So everybody see that. So you have the switch command, then you have the value that you're trying to trying to match it the value that you're trying to match, or variable that you're trying to match, and then what you have is different cases that you're matching it against. And notice here, for the first case, and then in single quotes, because this is char, case A, and a colon, all right? So after the command case, I would put a colon. Now, for that case, then I could have as many valid C++ statements after it. I could see out 50 different have 50 different see out commands after this case if I wanted. I could have whatever I wanted, do something else, whatever. It's going to execute them, all right? When it finished executing them, then it will what? Break out and end and get to return 0, all right? So that's what'll happen, all right? And for each situation, it'll do the same thing. So if it checks here to try to match let with the letter A and it doesn't match, then it'll go here and try to match let with the letter E. If it doesn't match here, then it try to match let with the letter I. If it doesn't match here, it goes here and try to match let with the letter O. If it doesn't match there, it try to match let with the letter U. If that doesn't match, it's just going to output you did not enter a vowel. Okay, so let's run this. All right, we run this code. Hopefully there's no errors. All right, so now it says, please enter a character. I can input any character. I can input a $sign. You did not enter a vowel. All right, I run it again. All right, say I'll put in a capital A. Remember, that's a lowercase a. Lowercase a and uppercase a are two different values, right? Hear that? You did not enter a vowel. But if I run it again and put a lowercase a, if I put a lowercase a, all right, you entered a vowel. So you see how the program checks? Now, there's one important thing when you're dealing with case, all right? And that's that break statement. See this break statement here? It's very important to know when you want to use the break statement. Because if I would take the break statement off of here and I put in the letter A, run the same program by just taking off break here, and I input the lowercase a, the program will fall into this case and output you enter a vowel, and then it'll fall into, and no break. So being that there's no break, it's gonna fall into the second case and output you have entered a vowel. And so I'll get two outputs of you entered a vowel. But then when it sees this break, it'll kick out. All right, so let's run it. And I'll put lowercase a and see what happens. You enter a vowel. Being that I did not have the break saying I want to break out of this, it outputted, it went into this one and it didn't care if this matched or not. I already fell into this case. So it's going to do all the cases until it hit a break and kick out. Okay, so you got to remember that. Now, sometimes it might be okay to have a case statement without a break. All right, and you say, well, how is that? What if I do this? I'll do case, lowercase a, case, uppercase a. So what'll happen here? And I got the break here. If I input either an uppercase or lowercase letter a, if it's lowercase, it's gonna fall into here. It's gonna stay into here, not output anything, but then it's gonna get here and it's gonna output you've entered a vowel. All right. So if I run it, I should get you have entered a vowel only once because it fell into the case with the lowercase a and then it kicked out. So you see how sometimes you may want to have multiple cases without a break because you're checking for multiple things, all right, and then kicking out. But you got only one procedure or process that you're performing given all of these cases, all right. Because I could have put case A, case E, case I, case O, case U, and then you have entered a vowel and break. I'd have got the same result, but I did each one. And then here I could add the letter A's. I could say you've entered the vowel A, when I split it up this way. All right. So it all depends on how you're writing your code as to what it's to do. So you got select, and then whatever that test expression, and then case, whatever the value, colon, and then whatever statements you got, and depending, you break. Case, the second value, then all the statements that you want to have could be one, could be none, and then break, and then the next one. All right. So, and until you finish, you do not have to have a default, but normally your default is if it's neither one of those situations, default, and then, you entered something invalid, or it cannot be computed, or whatever. And then you got your closed curly braces. All right. Any questions? Any questions? All right. So, yeah, okay. So here with this program, what it's showing you, they did it with a switch statement, but then now they're showing you how you can also do it with a if statement. But look how many different levels you have. And if depending on the number of test cases, your levels can become what? Very, 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 very deep, and could be very confusing when you have a lot of those open and closed curly braces, and you trying to align it and match it, and even look all the way over to the right of your screen and scrolling back through your screen. So, like I say, is it right or wrong? Nope. It's all in the programmer's style. Either one will work, but using the switch statement, everything is just switch. Just do this. If it's this, do that. If it's this, do that. And it's all going down in order. Otherwise, if you use the if else, you got an if else, then you're getting deeper and deeper and deeper. And like I say, if you had like say 50 of them to do, your screen probably, and if you're using the if else, your screen probably be all the way to column maybe 150, and then you got to scroll all the way back if you're dealing with those different levels. All right. So, but like I say, it's all up to you as a programmer as to how you would want to do it. All right. There's nothing wrong with it. Okay. So here we go with a switch statement. This is the flow chart. So we know that this is a switch. Whatever the model number is, it's comparing to see if the model is 100, comparing to if the model is 200, if the model number is equal to 300. Okay. If the model is 100, you're going to display whatever the price is. All right. And display the price. Look how you displaying it twice. Display price, whatever, and the size. Okay. And so here, if it's 200, display the price, display the size. If it's 300, you're displaying the price, displaying the size. If it's neither one, you're displaying invalid model. But once it finishes the switch, then it continues on with what? The program. Okay? So it's just going to continue on with the program. All right, and this is a small example, but this is still what? Pseudocode, class. This is pseudocode. Display would be what? C out, right? Input would be what? C in. All right, select would be what? Switch. And then in parentheses, you would have model number. All right, so you could take this and compare it to that online GDB program here. So if you compare it to this, switch, let, open curly brace, case. All right. So this is just pseudocode here. This is just your pseudocode. All right. But in the video notes, I used the 193 book, and you will see the actual code, and I explained the code also. All right, and it did something with the TV model, but it's a little different, but you should be able to understand it. Okay, now in your last program, I said something about logical operators in the little note at the very end, where I told you if gallons was greater than 25 and mileage was whatever. So the logical operators and are, and then there's one called not. Not is very easy to know, but it's sometimes very hard to, I would say, understand. And what I mean by that is, to know something is reverse, we know that. Yes means no, no means yes. That's easy, correct? But if you read in a program where x is equal to 3, and you say if x is greater than and x is greater than 2, you know that to be true, right? 3 is greater than 2. But then you see in a program, not x greater than 2. See, now what happens is the not just reversed all of that logic to make it true. Well, it'll make it, it'll make false true and it'll make true false. So that's all I'm saying. We know what the reverse of and are is, but sometimes when we're trying to read through something and determine whether it's true or false, we know that it's true based on the trueness of the information, but we get confused when we say, okay, it's true, but this makes it false. Because when you try to think of it a little later, you're like, oh, wait a minute, but 3 is greater than 2. So no, but the not reverse the logic, all right? 3 greater than 2, that's true. But the not says, okay, take the true and make it false. If it's false, make it true. So like I said, you can get confused. So the logical and or. Let's look at, we can look here, all right, and see what it says. And the and operator connects two Boolean expressions, something like x greater than 2 or and y less than 5. Okay, so it's going to have those two connected and then do this, then do that with the and. Or is the same way, all right? So it connects two Boolean expressions into one compound expression. Both sub-expressions must be true for the compound expression to be true. Okay, what do we really mean by that? Let's go to our SYL site and let's look at our Boolean table. All right, where is it? Right here, our Boolean truth table. All right, so if I pull this up, all right, now if we look at this table, we see this is the truth table. This is the and truth table for the and, the truth table for the or. Now you say, okay, what does that mean, Mr. Sylvester? What that means is P represents a Boolean expression such as x greater than 2. Okay. Q represents a Boolean expression such as y less than 5. So if the P portion is true and, remember our and this is our and used in C++, and y greater than whatever we had is true. So if the P side of that Boolean expression is true, and the Boolean expression for Q is true, with and, the whole evaluation of that if logic would be true. Okay? Let's continue, then I'll show you in the program. If the P side is true and the Q side is false, then we would then the whole expression would yield to be false. If the P side is false and the Q side is true, it still will yield, with and, it still will yield the whole expression to be false. If the P side is false and the Q side is false, the whole expression yields to be false. All right, so let's go to online GDB. And I'm sorry, I didn't increase the size of the screen the last time I showed this to you. All right, so let's modify this program. All right, so what we're gonna do, we're gonna take this switch statement out. All right, we're gonna take this out. Okay, and we'll say enter num 1. Well, I won't say enter num. I'll set the number. All right. Okay. So I'll just say int x equals 3, y equals 2, z equals 10, or whatever. It doesn't matter. 10. All right. Now, here we go with that and. I could say something like if x is equal to, if I could type, equals 3, and, well, I don't really need this, but I'll show you it later on, and z greater than y. Now, okay, see how, all right, so I'll do that. Else, if I could type, all right. So looking at this, what will output? First of all, is x equal to 3? That would be what? True. All right. Is z greater than y? That would be what? True. So look at this. This side true, which would be the P. This side true, which would be the Q. So true and true yields true. So it will output what? The expression is true. All right. So let's run this. Let's test it. I'm gonna pick this up. Huh? See, expression is true. I'm gonna open this up a little bit so you can kind of see the code. All right. So expression is true. All right. All right. Expression is true. So now, true and true yields true. So let's change this to not. All right. If x not equal 3 and z greater than y, is x not equal 3? That's what? False. Even though z greater than y is true, false and true yields what? False. So now it should output what? Expression is false. So if I run it, expression is false. So you understand what happens. If I have an if condition, if I have a logical, this logical operator, and I use and, both sides of this and has to be true in order for me to perform the true logic, right? And like I say, in this if, I can have any other statements, any other if statements, whatever, anything I could call functions, whatever I want to do, I could do it in this true logic. But if this yields to be false, if any side is false, it make this and false, and it will do anything that's in this body of this else. Okay, so that's what I'm trying to tell you about. Now look at this. I could do something like this. We can build on an expression. All right. Now what that means is I could extend it more than what it is. So I could say if X is equal 3 and Y greater than, Z greater than Y, and then I'll do another and then I'll say X greater than Z. All right. All right. So what I have to do here, and if I group it, it makes it all the difference. All right. Because remember, anytime you have parentheses, you got to work from what? Within the parentheses outward. Remember that? So now, looking at this, I must do what first? What's inside the inner parentheses? So X equal 3, true. Z greater than Y, true. So within this parentheses, that all yields to be what? True. But then we have this true and X greater than Z. Is X greater than Z? No, that's false. So true and false yields what? False. So it should output what? Expression is false. So see what happens? Just because the first part of it, remember when we did it with just this alone, hey, it yielded to be true. But when we added another part to it, we had to, based on our parentheses, we have to evaluate this and then evaluate this and then get our results. So I'm gonna run it and it should say what? Expression is false. You understand? Because I did this, true and true yields true. But then I need to bring this down, true and false yields false. All right. But if let's go back. Hopefully everybody understands and both sides has to be true. All right. Just like I gave the Coke machine example. If I gave a student some money to get me a drink and I say, bring me back a Coke and a Sprite, they should come back with what? Two of them. Right. Because they both have to match and they both have to be together. But if I say a Coke or a Sprite, now you have a decision. You can bring one or the other. All right. So now let's look at the R. With R, let's go back to our notes. With R is a little different. With R, the P expression can be true. The Q expression can be true. It yields true. The P expression could be true. The Q expression could be false. But if what? If only one side is true, it makes it what? True. The P condition can be expression could be false. Q expression could be true. It still yields to be true. All right. If it's R, all right. But if they both false, we know that what? It's false. It should be false. So let's go back to our online GDB and let's do this. If we did this, just left everything the same and put R here. Now that R is the normally on all keyboards, the holding the shift key and the backslash. See how we got backslash in? That particular key for the backslash, holding down the shift, that's that pipe symbol that is used to be the R. On some keyboards, that line is got a split between it, but the newer keyboards they don't. All right. Now, so let's look at this. When we look at this, we still have to solve from what? Within the parentheses. So X equal 3. That's true. Z greater than Y. That's true. So all of this is going to yield true. But now we have what? R. So even though we see an expression here, if this is true, this automatically makes what? The entire expression what? True. You got me? Why? Because we done solved for true or true here, which made it all true. So then we say true or could be false, would be true. True or true, it still be what? True. So that's all I'm saying. But if we look at it, we got true on this side, but then we would say Z, X greater than Z, that's false, but true or false still yields true. So it should say what? Expression is true. So when we run it, expression is true. So now, what I was saying was, sometimes we get confused. If I do this, all right? If I do this and right here, oh, what did I do? I used the control key. Let me go back. All right, if I do this, what have I just done? I've just taken x greater than 3, x equal 3 or z greater than y, and made it what? The reverse. So if that or condition yields true, I'm telling it is going to be what? False. Everybody understand that? The not reverses whatever the logic is, the actual logic is. So x greater than 3, that would be true, correct? Z greater than y, z greater than y, that's true. So all this would be what? True. But now what? I have to say what? Not. So that makes it what? False. So now x greater than z, that's false. So false or false yields what? False. So if I run this, it'll say expression is false. All right? So you understand, even though we understand reversing something is the opposite, but when we start looking at something and saying it and then have to take it in our minds and reverse it, sometimes it get a little confusing, and we got to hold on to that. You know, as we go through the expression, we forget or we get confused, and we got to keep going back and forth. But the not just takes whatever that expression actually is and reverse it to what like say if it's true, reverses it to false. If it's false, it reverses it to true. Okay? Everybody understand that? I know it's kind of somewhat kind of complicated, but you know, that's how it works. All right? Everybody see that? Okay. Now, then, well, like I said, that's in another class. We ain't gonna worry about that. So let's go back to our notes. So that's the and, the or, and then the not. So looking at this, it says, well, it didn't give us any values, but what it reads is x greater than y and a less than b. Now, in order for this to be true, what? Both sides has to be what? True. Now look at this one. X equal y or x equals z. What here, for this to be true, either side can be what? True. They don't have to be both true, just either side. Now look at this one. X greater than y. This says if x is greater than y, it would be true, but the not will make it what? False. All right. And if it was false, the not would make it true. All right. And so that's all these expressions are saying. Now look, you got to remember one thing also when you're writing code. You cannot say x, 20 less than x less than 100. Like normally in our math classes, we can somewhat do that with a variable. We could say 0 less than x less than 10, and x would be anything in between that value. But in computer science, you have to compare both sides you have to have a Boolean expression where you have temperature less than 20, all right? So you got this compared to this, and this compared to this. It has to be something that's compared to something. I can't say temperature less than 20 and greater than 12. Can't do that. Or temperature less than 20 and greater than minutes. Cannot do that. Minutes has to be compared to something or something compared to minutes. All right? So you have to do that. That's very important, because sometimes you start writing code and you run into those issues. Now, this is our table class, basically, what we looked at when we was in on the SYL site. True and false is false. false and true is false. False and false is false, but true and true is true. All right? Now, in the OR operator, here's the same thing. The table is just represented in a different way. True or false yields true. False or true yields true. False or false yield false. And true or true yields true. All right? So that's something we got to keep in mind. Got to keep that in mind. And like I say, the not operator, man, that not operator can get you very, very much confused. But like I say, especially when you're trying to go through it and evaluate it, all the not says, look at this. If not temperature greater than 100. That's like saying what? If temperature is less than 100, correct? What's his name?
He's Gimli because he's a dwarf dog. So
okay. All right. Oh boy. So like I said, this is saying like if temperature is less than 100, because what? Temperature greater than 100, but if it's true, we saying not, so we're making it false. So the false condition is the true. All right. So we're gonna do this if it's not greater than 100. All right. So you got to be aware. You got to be careful. You got to be very, very, very careful. Okay. Not true is false. Not false is true. All right. Simple as that. All right. So, and next thing, make sure you remember your greater than, less than, greater than or equal to, less than or equal to is a double equal comparison. Not equal to, greater than, less than. All right. Make sure you remember those. Okay. Now, this program pretty much deals with a salary and the number of years a person worked on the job. So, and I have it in the listing of videos, and they have the actual code. But we can look through this. It says, okay, display out what? See out. Enter your annual salary. Then what? Input or see in salary. So you're going to input a salary. But what happens is, based on the salary, and then based on the number of years, it's going to determine whether or not you qualify for a loan. So if we look at this, it says, if salary, and that would be parentheses, lowercase if, and then parentheses, salary greater than or equal to 30,000, and year on job is greater than or equal to 2. So what? In order for it to say you qualify, a person has to make a minimum of $30,000 and has a minimum of 2 years on the job. Anything else, if it's less than $30,000, they won't qualify. If they only have like a year of experience and they can have $60,000, they won't qualify. So you understand, both sides of that expression has to be true in order for it to say you qualify for the loan. Okay? So you got to watch that. So if you look here, $35,000 one, they don't qualify. All right? But $25,000 five, they don't qualify because what? The salary doesn't hold up. But then what? 35,000 and 5 years, they do qualify for the loan. All right? Now, basically, they pretty much did the same thing again. All right, CN salary. All right, CN. Right here, CN the number of years. But then they asked the question again: if salary greater than 30,000. But look here, or that makes a big difference. Look here, this one said what? And so the difference in the two is with this one, they had to make $30,000 or more, and they had to have 2 or more years. In this program, they could make $30,000. Anybody who make $30,000 or more automatically qualifies, or anybody who has 2 years or more automatically qualifies. Either one, not both. So that's the difference in those two programs. And the only thing was changed was what? The word and or. All right. So you see, when you writing code and you writing code for a business, those simple greater than, less than, and R's can be a crucial thing in a program if you don't program it right. So that's why you have to test and test and test all conditions to make sure it is doing what you want it to do. Don't ever just take it for granted. All right. So let's look here. And this one got R. So if salary is greater than 30,000, once that happens, it automatically you qualify. Okay, if salary greater than 30, say they make 25, but then they have 5 years. Oh, they automatically qualify because they have 5 years. All right. But if they have 25, they make $25,000, and they have 1 year, they won't qualify. All right. So if both of these have to be false in order for it to say you do not qualify. So let's look here. $35,000, they automatically qualify. You qualify because it's not concerned about the number of years after that. This one, $25,000, but 5 years, you automatically qualify because this one would hold false, but then the 5 years is greater than 2, so that would make it true. But look at this one, $12,000, don't qualify, be false, and 1 year, be false. So what? You do not qualify. Okay, so that's all that's saying. Now, checking the range, numeric range of logical operators. So a lot of times when you're writing code, you might want to check values between a certain value. Like you might say, well, I'm writing this code here, but I only want to use the input values between 10, that's equal to 10 and less than equal to 20. So what you would say is, if X is greater than or equal to 10 and X less than equal to 20. So that means everything in that range would be valid. All right. So it says sometimes you will need to design an algorithm to determine whether a numeric value is within a specific range. And that will be understandable. All right. A values outside or a range of values outside of a specific range of values. When determining whether a number is inside a range, and it's telling us, and this is good hints to keep in mind, it is best to use the AND operator. So if you're trying to find a range that's in between numbers, it's best to use AND, all right? And it's telling you that, and that'll be good practice from now on, okay? For example, the following if-then statement checks the value of X to determine whether a range is of 20 through 40. And like they say, use what? The AND operator, our logical operator. So now all you would do is what? If X, you including 20, is greater than or equal to 20, and you got to use X again, X less than or equal to 40. Bam. Any number in between that is good. Because what? 22 is greater than 20, and 22 is less than 40. So that's included. If I type 10, if I would input 10, 10 is not greater than or equal to 20, so automatically it would fall out the range and it would be false. If I inputted 45, 45 is greater than 20, but it's not less than equal to 40, so therefore it falls out and it is false. So you understand it's best for that. But look what it says here. When determining whether a number is outside the range, all right? Now you want to determine if a number falls outside the range. It is best to use the OR operator. So here when I use the AND, it says this one should be, or hopefully it's checking for values that are included, all right, in that range. This one here with the OR is checking for values that are less than 20 and greater than 40, all right? So look here, because what? 10 cannot be less than 20 and greater than 40 at the same time. Everybody understand that? So it says if X is less than 20 or X is greater than 40. So what? 10 is less than 20. So therefore what? It would be true. And so you would what? And now your logic is pretty much reversed. Now it says what? The value is outside. And then if it's 45, 45 is not less than 20. All right. So therefore it's automatically, well, 10 is less, but it's not greater than 40. Excuse me on that point. But then 45 is not less than 20. So therefore it would not be a part. So it would fall into this where it would print out outside the range, all right? Because it is great, it would be greater than that, would make it true, and then that's your negative response, all right? So you check to see if it's included with and check out excluded with the or, all right? So let's use that example in this code, all right? So I'll do something like int x, and then I'll do something like this. I'll see out into a number. All right, and we know our number should be, well, and then what? Cn x. Now, so, and here, if we want to include it, what will we do? We have to do the and, right? If x is greater than or equal to 20, and then what? It say use and x is less than or equal to 40, all right? See how? I'll just put great job here. All right, number out of range. So when I run this, if I enter a number like 10, it's gonna give me number out of range. If I enter 45 or whatever, number out of range. Anything greater than 40. If I enter 22, it's gonna say valid. Oh, good job. All right. So when I run it, let's run the program. I got an error. CNO semicolon here. All right. Control V. Semicolon. All right, so let's run it. All right, so it's saying enter a number in the range of 20 to 40. All right, so say I enter 10. 100. 10. All right, and now expression say if x is greater than or equal to 20. 10 is not greater than or equal to 20, right? So that means this and, by this being false, automatically it's going to just say what? Number out of range, right? See, number out of range. All right, but if I run it again, all right, say I'll put 41. 41 is not less than or equal to 40. So still gonna put what? Number out of range. All right, but if I run it now and I say, I'll put any number, I'll say 33. All right, well, look, the 3 is up here. Let me run that. Let me stop it because some people might get confused. Run it. 33. 33. 33 is greater than 20, and 33 is less than 40. So both conditions are true. This is and, so it should say what? Great job. So you understand? That's how the if statement works. And like I say, throughout your programming career, you're going to be using if statements. But in the next chapter, we're going to be using loops. And what loops does, it allows you to continuously execute code until something happens or for a certain amount of time, iterations, etc., which makes your program more functional. All right. Now, it says something that like what? If we wanted to exclude numbers, we use what? Or, but we have to change our logic also. So I put or here, but now I need to say what? Less than 20, right? Or greater than 40. But see, the thing is, I need to reverse this logic here because what? If it's less than 20 or greater than 40, it's invalid, right? So now I need to take this and cut it, and I'll paste it here. And I'll take this one and cut it and paste it here. So now what? If the number is less than 20 or greater than 40, the number's out of range, all right? Otherwise, great job. Okay, so you see, and then sometimes you might not want if you wanted everything that was less than 20 and greater than 40, then you would just reverse these output comments, all right, or output statements. So if I run this program, all right, if I put in, I could even put in 20. If I put in 10 or 19, 19 is less than 20. That's true. So it don't have to worry about the next R. Number is out of range. So it's going to say number out of range. If I run it and I put 44. Let me run it again. I'm doing it too fast. Run it. And I'll put, it's 44. All right. All right. And I run it and I hit enter, number out of range. But now if I run it and I put a number inside 40 and 20, I could even put 40. 40 is a part of it. I hit enter, it say great job. Okay, so and or. And like I say, you change your logic based on the two. All right? Anybody with any questions? Any questions? Where's the notes? Notes are here. All right. Now, this here can be a little tricky. A Boolean value, all right? What it does, it can hold only two values, true, false, yes, no, on, off, 1 and 0, okay? Now, with that, okay, and it explains, you could read this, but what I'll show you is, I'll go to the program, I think I could better explain it if I show it to you, all right? So if I do something like this, and I'll say, I could use X. Boolean X is equal to false. All right, so I'll say X is equal to false. And what I'll do here, I could say, enter a number. Just enter any number. All right, enter a number. Now, here, once I do this, I can ask the question, not X, I'll say a Boolean flag. I'll say flag is false. I'll say int X. All right, so I'll see in an X. I'll say if X is greater than 10, all right? So if X is greater than 10, what I'll do something like, I'll do this. I'll say flag, oh man. I'll say here, flag equals true, all right? If it's greater than 10, otherwise it's false, and I'll just say flag equals false. Okay, flag equal false. All right. So then I could go down here and say cout, and it might give me 1 or 0. All right. Cout flag, because it's a value. It's a value, not an actual string. All right. So if I run this, I'll run it. Let you see. It's gonna be a value. So if I put something greater, wow, I got if. Y'all let me do that. Haha. All right. Here we go.
Hey, Gimli, come on.
Haha.
Gimli.
All right. See,
What?
I put 12. Now what it did? True is 1. False would be 0. So watch this. Let's run it again, and I'll put a number less than 10. I'll put 3. Look what it printed out. Flag is 0. So when flag is true, it's 1. I mean, yeah, when flag is 0, it's false. Now, so what I can do here is say something like if flag, all right? If flag. Now, what does that mean? That means if flag is 1 or any number that's other than 0. If flag I can tell you. All right, X is greater than 10. All right. So now, what I've just done, let me show it to you in the program. So I set my flag to false. All right, so flag is false. I'm gonna input X. I'm gonna input the first time I'm gonna do it, I'm gonna input a value greater than 10. All right. So that will allow my flag to be changed to true. Now, then I'm gonna ask if flag. Now, what that means is if flag is of a value other than 0, right? So in order for flag to be true, it has to be any value other than 0. 1, 1, -1, -1,000, 1,000. But if it's 0, then it'd be false. So now, I have if flag. All right, that means if I put a number that's greater than 10, my flag should be true or 1. And that means the number is greater than 10. Otherwise, the number is 10 or less. I'll just say 10 or less. All right, so let's run the program. All right. So I run the program and I put, say, 100. Put 100, see, X is greater than 10. How does it know that X is greater than 10? Because my flag. I told it flag is 0, but I inputted X and I said if X is greater than 10, change my flag to true. So now it knows that the flag was changed to true because X was greater than 10. And I printed out my prompt, X is greater than 10. But X is greater than 10, but what is flag equal to? 1. Flag can only equal to what? 1 or 0 because it's of what data type? A Boolean value. All right. Remember I say true, false, yes, no, on, off. Right. That's the only values that flag can equal to. Now, what if I did this, class? If I put a not. What have I just done? I've just reversed my logic in that if flag, meaning what? If flag, this asking if flag is 1, all right? Or if flag, if it is flag, take it and reverse it. So it is true. If it's true, take it and reverse it and make it false. So if I run this program and I put in 100 this time, it's going to output X is less than 10. Or X is 10 or less. Because I'm asking for the what? The not flag, all right? So when I run it, and I put 100, see here, X is less than 10. So it evaluates the expression, flag was 1, right? But this not turns it to 0, then it solves this, and it says, okay, it's a false, so it's gonna do this false expression, even though I know I put in a value greater than 10, right? Now, you can even have this set to 0, okay? So I have flag set to 0. So here, if flag is 1, if X is greater than 0, flag is 1, otherwise flag is 0, all right? And that's what the program is doing. So now when I run it, it's gonna give me the same exact result. So if I put 100, so you understand X is greater than 10. So you gotta understand a Boolean value can be 1, 0, 1, on, off, yes, no, true or false, all right? But I'll show you another thing here. I could ask if X. I could ask if X. Now, what this saying is, if X is any value other than 0, any value other than 0 makes X true, all right? So let's run it and let's see. Well, let's see if I want to do that. Yeah, okay. If X. So it's not just saying, well, I will say if X, okay, and I'll put X exists. Okay, and I'll say here, X is 0. All right, so now, right now, we're not worrying about the flags. The flags are irrelevant now because, and I could take them out to show you. I'll take that if logic for the flag out. I could take the Boolean value out. I'll take this out, all right? And I'll take the flag because that's on it. I'll take that out. So all we're doing, we're dealing with X. Now, so I input a value for X. If I put anything other than 0, it's gonna say X exists. If I put 0, it's gonna say X is 0, all right? So when I run it, all right, I could put 2, X exists, all right? Run it again. I'll put -99, X exists. If I put run it again, if I put in 0, now it's gonna say X is 0. What happens is, and then if I put that not, it's gonna reverse all my stuff. So we gotta remember about the not. When you take it like this, if you was writing a program for a bank or a banking system, and they needed you to write code to determine all accounts that had 0 balance. Now, grant you, we know that some accounts can be negative, correct? So we want those accounts listed also. But anything with 0 balance, we don't want. So what you could do is ask if, and if amount was the variable, if amount. So if amount is 1 to infinity, you can amount would be a valid output to a record to output. If amount was -1 to negative infinity, it would output those values. But if amount was 0, we can what? Exclude all of those records. So you understand that that's one way of understanding how you can use a if statement and check to see check for its value for whether or not it exists or doesn't, using a 0 and 1. Because what? Any if logic gonna returns a what? A 1 or a 0. Now, but the 1, normally it would be always true. But anything other than 0 is true. Okay? So that's something you got to understand. So when it say if amount, all right, just like I said X, if I say if amount is any value other than 0, it would exist. If it was 0, then it wouldn't exist, or it would be 0, and you can eliminate it. Okay, so that's the logic for that. So we're at the end of the chapter. How would do that? Our test class, our test. Do I still have? How much time I have in class?
We are
over. Oh, okay. All right. Okay. All right. So, the test. What I'll do, class, being that everything is online or whatever, I'll post the test. I won't put a password on it. I'll give you like I say, a time frame in days, like say maybe from what today is. Today is Tuesday. I'll say from today until next Tuesday to take the test. You can take it at home or whatever. Take your time, get the right answers, whatever. But it should have a time limit on it. So, but take your test. You still have your 2 options to take it. And do my programs. All right. Hopefully those small videos of those sections will help you with your programs and whatnot. But we're gonna try to stay on track. And next chapter is loops. And with the loops, like I said, we're gonna learn how to continuously do something. And I'll just give you we over, so I'll do that on next class period. So read up on your chapter, do your in the chapter questions, and take my test, but also do my assignments. All right, and I'll see y'all on next y'all want to have class on Tuesday? Because being that they're online, we don't have to meet, but if you all want to meet, we can meet. Hello?
Yeah.
Yay, nay, what?
I have no strong opinion one way or the other.
All right, anybody else?
I'm okay with it.
What? Class Tuesday?
Yeah.
All right, okay. So what we'll do now, want to continue on with chapter 5, all right? And I'll try to put some small videos out there also for starting with chapter 5 again. All right? Okay?
Yep.
All right, and take y'all test. All right, see y'all on Thursday.
Thursday.
All right. Have a good one.
Later.
All right.